Hi everyone. Um, in this lesson, lesson 3 of logarithm, we have three laws of logarithm that we want to prove. These are very common in logarithm. They are log of a number times another number with a particular base is equal to log of the first number with this base plus log of the second number with the same base. So we want to prove this. We want to show that this is actually equal to this. So what do we do? Let us consider the left hand side. On the left hand side, what do we have? We have log of xy base a. Log of xy base a. So what we do is we say, yeah, actually the base is a. But let's go to the log number, the logarithmic number. We have a particular law in logarithm that says whenever a number whenever a number is raised to a power, but the power is a log, this log has a number and this log has a base, but the base is the same as the original base here. A number is raised to a power, but this power is a log. It has a number, it has a base, but the base is the same as this one. So this is equal to the log number. When this one, you have something like this is equal to x. Now let's say again, we have, let's say t raised to a power, but the power is a log. This log has a value, a number, and a base, but the base is the same as the original base here. When this one happens, what is all of this equal to? It is equal to this y. So this tells us that if we want to create the same thing with x, we can say what? A number, any number, let's say b, is raised to a power, but the power is in log form. A number b raised to a power, the power is in log form. This log has a number. Now we want to create that of x, a number x, using what? A particular base which must be equal to this. So when you have a situation like this, this is equal to x. But we don't want to use another base other than the a here. So what do? We say for this x is the same as any number, let that number be a number, raised to log. This log has a number which is already x, and the base is this one here. So x is equal to a raised to log of 9 base a. X is equal to b raised to log of x base p. X equal to b raised to log of x base p. This is equal to x, this is equal to, the base does not matter. What matters is that the base here must be the same as this base. So that means if you have a pattern like this one, this x is what is equal to, that is representing all of this one. But between x and y, there is a multiplication sign. So we say multiply by y again is the same as any number. We want to use the same number, a raised to a power. The power is a log. This log has a number which is already y, and the base of that log is a. So you see, a raised to log of a number with the same base a. A raised to log of a number with the same base a. When it happens like this, the result is y. When it appears like this, the result is x. And between x and y, there is a multiplication which is here now. Okay. So what is next here? We say we have a here already. Okay. This is what? A raised to a power times a raised to a power. So if you have x to the power of 2 times x to the power of 4, what do? We take one base. Then because of multiplication, we add the powers. So we say 2 plus 4. So base A, separated by multiplication sign. We take one base. So what do? We add the powers. Log x base A, log x base A, because of multiplication plus log y base a. Okay, so finally, what do we say now? We go to another log that says log of, if I look at it here, when the log number has a power, the power goes to the left side of the log. You see, log x to the m base a is equal to m goes to the left. Look at it, m log x base a. So now let's see here again. What happens here? The number here is a. A has a power, though it's an expression. So when this one happens, it goes to the left. So we say log x base a plus log y base a. The log number has a power that goes to the left. We are left with log a base a. This is what we are left with. So in that case, what happens next now? What happens next? Log of any number to the base of the same number is 1. So if this is 1, 1 times this bracket, what remains is the bracket. So this is now equal to, this implies log x base a plus log y base a. So we can see that originally this one is equal to this, which is this one here. Now let's go to the second one. The second one again, let us consider the left hand side. The left hand side. What is the left hand side? It is log x. The left hand side is log x over y base a. So what is next here? So we say we maintain the same a. The number is what? A fraction. Now let's go to x. What is x? X is the same as when a particular number is raised to a log. That log has a number which is already our x, using the same base as this one. The same thing we did here. We are repeating something just similar. So to the denominator again, y is the same as when a number is raised to a log. Is raised to a log. The log has a number which is already y. Then we maintain the same base. Yeah. So now we say we still have our base a. Okay. So what happens if you have like a to the power p, a to the power q? So it means the bases are the same. For division, we subtract the powers. So a to the power p minus q. So here again is the same. Base a, division. So we take one base, which is what? A. Now this one has log x base a. This one goes up minus log y base a. Okay, so we are here now. We are in the log number has a power. The power goes to the left hand side of the log. So we say log x base a minus log y base a. This is the power. This is the log number. This is the base. So when the log number has a power, the power goes to the left hand side. So this one has come to the left. Then what is left here with us is log a base a. But what is log a base a? They are the same. It is 1. 1 times the bracket is the bracket, which is log x base a minus log y base a. So we can see that log of x over y is actually equal to this one. Okay. Now we are going to the same thing again. Yeah. We want to show that when the log number has a power, the power has the right to go to the left. Yes, and everything here remains the same. Okay. Now what do? We consider here the left hand side, which is log x to the power m base a. Okay. So we say the base is already a. What is x? X is when a number is raised to a log, and that log has a number which is already x, we maintain the same base, which is what? Which is a. But do not forget that there is m. There is what? M. Now come to think of this. If you have a to the power 2, a to the power 3, this base has a power inside, has another power outside. The powers multiply themselves. So here you will say the base is a. This a has this a has a power which is what? Log x base a, has another power m. So what happens? M multiplies log x base a. So what is that? So say this a is what I just wrote here. This a is this one. So how about log x base a and m? Log x base a is a power of a. M is a power of a. So when you have two powers, they multiply themselves. So m times log x base a is m log x base a. Okay. So what is next now? The log number has a power, and that power gets to the left hand side. So we say m log x base a. So what is left now? Log a base a. So log a base a is 1. 1 times any value is the value itself. So which is m log x base a. So we can conclude that whenever the log number has a power, the power has the right to come to the left of that log, and everything remains the same. So thank you for watching. Don't forget to follow, like, and share. See you in my next video. Bye bye.